Today's lesson is estimating area. We've already worked on estimating perimeter, and we just finished working with the area of quadrilaterals and triangles. So the goal is I can estimate the area of irregular figures on a grid when you cannot break them into common figures. Also, I can use correct units. Here's a joke to get us started. Uh-oh, here they come. This could be a problem. Make sure you have your estimating area notes next to you, and let's refresh our minds of this. So when we worked on estimating perimeter, I gave you this picture and I said, how could we estimate the perimeter, the distance around Lake Superior? It's not a polygon, is it? No, it doesn't have straight sides. And so we talked about, well, could we bring in polygons? Yeah, we could use a grid. A grid is filled with polygons. In this case, squares. So we're going to do the same thing today, except we're not looking for the distance around the shape. We're looking for how much area the shape covers. So we're going to be looking at how filled in each of these grid squares is when it's covering the shape. Here's our figure today that we're going to estimate the area of. And when we do this, we have to look at how filled in each one of the grid squares is that covers the shape. So this grid square right here, it has nothing to do with the shape that I'm looking to calculate the area of. This grid square does. When we're looking at these grid squares that cover the shape, we're going to look at how filled they are. Is it filled almost all the way? Is it filled about halfway? Is it filled partially? Or is it filled completely? So just like with estimating perimeter, we have a really handy chart to help us. So if the grid square is less than half filled, so if you look at your two pictures here, we're going to say that it has an area of about 0 square units there. If it's about half filled, like you see the two images there, we're going to say it's about half square units. If it's more than half filled, like you can see in the last two examples there, we're going to say it's about 1 square unit. And if it's completely filled, like right here, 6th graders, where my cursor is, we're going to say it has an area of 1 square unit. So we're just going to go from top to bottom on this shape and identify how filled in each grid square is. So looking at this first one here, about how filled in is that? If you look at the picture over here, it matches about the half. So go ahead and write half in that one. Look right next door. This one is the same, about half. Going down, this one right here, now it doesn't have a perfect match to a picture over here, but if you look at this grid square, I would say it's about half filled in. Go to the one to the right. This one is almost all filled in. There's just an itty bitty part at the top left corner. So we'll say about 1. Same thing here, about 1. Looking at how filled in this grid square is, it actually matches what's over here. So it is about a half. Working down to this one right here, it's not completely filled in, but man, it sure is close. So we'll say about 1. This one is completely filled in. So this grid square right here is going to have an area of 1 square unit. This one is going to have an area of 1 square unit. This one right here is just about filled in. You have a little part missing. So we'll say that this grid square here has an area of about 1 square unit. Right down in here, how filled in is this grid square? What picture would it match over here? About a half. And here's where you might go, gosh, Miss Kluver, it looks really close to being a whole. And we might vary a little bit with how we're seeing things, and that's okay. This one right here is completely filled in. This one right here is completely filled in. This one right here is going to match the other one. Remember, if we cut this shape in half, just like I talked about with perimeter, and folded this side on top of this side, they're going to match perfectly. It's symmetrical. This grid square right here, what do you think would match over here in the chart? Probably about half. This one right here, probably about half. This one down here, half of it is filled in. This one right here. Remember, you're looking at how filled in this one grid square is. With that figure, it's about half filled in. So now what we need to do to estimate the area is we just have to add all of our individual grid square areas up. So remember, 2 halves make a whole. So we have a half and a half, that's 1. A half and a half, that's 2. 3, 4, 5, 6, 7, 8. A half and a half, that's 9. 10, 11. Half and a half would be 1 more, 12. Half and a half would be 1 more, 13. So the area of this irregular figure, which is not a polygon because it doesn't have straight sides, would be 13 units squared, or square units. Or you can abbreviate units with just a U. So 13 units squared, or 13 square unit. And again, we might vary within a couple numbers here, like maybe you saw this one as almost all filled, and I get that. We're gonna see a few things a little differently, but we should be close to each other when we're doing this. All right, that is the end of this lesson. You're just gonna work on estimating area, and the hard part is gonna be sixth graders estimating area and then estimating perimeter. So really having both of those notes next to you as you continue forward in this unit, because I'm gonna start putting estimating area and estimating perimeter together. And the charts are a little different because when it comes to perimeter, we're looking at the distance around the outside of the shape. And when it comes to area, we're looking at how filled in, or how much space the shape covers using our grid squares. So we're looking at how filled in these grid squares are. So we have to differentiate. We have to be able to tell the difference between perimeter and area. And these charts can be really helpful.